Is everyone able to see me and see the screen?
Yes.
Okay, great. So it's 1 o'clock. We can get started. If you haven't already, for like the fifth time, just scan the QR code. If you have any difficulties, let me know. Otherwise, I'll go back to it at the end. If you're just now scanning it, you're going to scan it. It brings you to a website called Penji. If you need to log in, you sign in with your school like email. You navigate to coding your success and you just click join event. It's just for attendance. So, if someone needs to know that you attended the event, that's how they know. All right. So, all right, let's get started. So obviously, as the title implies, this is Code Your Success, study strategies for mastering computer science. So we're going to focus broadly on study skills, resources, and strategies that will help you just study, obviously. And as we go along, we'll gear it more and more toward computer science. So just to start off, this is a bit about myself. My name's Dan. I was a computer science and a computer engineering undergrad, and I'm currently getting my master's in computer science, so I'll graduate in next spring. I'm a graduate assistant for supplemental instruction, which is a free tutoring resource here on campus. Basically, it's like sort of like a peer tutoring system where you go and you work with your SI leader who will help guide you through the content and help you come to a deeper understanding of the content. You'll learn how to learn the content. So, the most effective ways to learn and retain the information from the class, things like that. I was also an SI leader for Intro to C, so I've kind of done it before. I know some of the more common pitfalls when people take that class. So if you're in like Intro to C, concepts in computer science, Intro to Discrete, or all sorts of other undergrad level courses, I'd strongly recommend attending. So I first wanted to start off with the computer science flowchart and just sort of get a rough count of who is where. So we sort of have our intro level, concepts in computer science and Intro to C, which is sort of, your freshman year type of class. You sort of graduate along to Comp Sci 1, logic and organization, discrete, and all the way up until the final exam, foundation exam, right? And after that, you get into your upper level electives, CS2, POOSed, processes and object-oriented, and finally senior design. So if you want to either unmute or put in the chat, like roughly where in here you feel like you belong, whether it's like what year you are in college, what class you're taking right now, something like that.
Intro to C is what I'm thinking now.
Okay.
CS1.
Okay, cool. Yeah, Intro to C is like the big first one,
Yeah.
I know people have their opinions about C, but I am a big C fan. It's very important.
Oh, yeah. No, it's not. That's just learning it and
Mm-hmm.
Yeah.
All right. Anyone else? Okay, cool. So yeah, Intro to C and Discrete. Discrete's another one where it's definitely a learning curve, especially like if you come from a non-CS background into college, right?
I would take that one and yes over the summer.
Mm-hmm. Yeah, that's good. Sorry, I was just making sure Discrete isn't a prereq for CS1, but it's not, so that's totally fine. I think they changed it. I feel like it used to be,
Oh, okay.
but cool. So we're going to start off with an overview of the foundation exam. If you are in the first half of your school semester or your college career, I'm assuming you want a lot of information about the foundation exam. Even when I was an SI leader for Intro to C, everyone came in and would ask me about the foundation exam. So it's not all that this presentation is going to be about, but I'm assuming it's relevant, so we'll go over it. A little bit of information about it. Typically offered on the first Saturday of each semester to students who have passed Computer Science 1. So it's offered once per semester, I believe. I got my information from the website. So if for whatever reason it changes, don't blame me, because as of right now, this is current information. Upon passing CS1, you have 3 semesters, 1 year to pass the foundation exam. The big thing about the foundation exam, the big thing that stresses everyone out is seeing if you do not pass it within 1 year, you aren't permitted to continue in the major. So essentially you get 3 shots to pass. And if you don't, unfortunately, you're not going to be able to pursue a computer science degree. So there's 4 sections to it. There's data structures 1, 2, algorithm analysis, and general algorithms. And I have some further information on what's included in those sections here. But it's probably better if you actually just look at it using these links. So there's the official foundation exam website, which has the information I just gave you and a whole lot more. So it also has all of the previous foundation exams, which, as we'll talk about, is a really useful resource. You get like a little, not like a cheat sheet, but like a formula sheet of sorts that you can use on it. So you can see what you'll be provided when you go. It also just has, tips, more information about the exam, so on and so forth. And you also have Professor Guha's website. I don't know if any of you have taken a course with Professor Guha or, know of him. He's very big in making the foundation exam. He has a lot of really good resources. He uploads his notes for free. They're accessible to everyone. So I always really recommend that people, check those resources and understand the conceptual points that he makes. Okay. If you have any other questions about the way the foundation exam works, for instance, what do I need to pass? That's probably the big one. I would just go on the website. I can tell you now, short answer, it changes every year. It depends on people's scores. You should just aim to do your best. So we'll talk more about the foundation exam as we go along, such as actually right now. So why do you guys think we have the foundation exam, other than to be mean and spiteful? Just, you can shoot out your best guess, your best, theory.
I heard of something where most computer science graduates, they graduate and then it's like they don't know how to code. Like I heard of that phenomenon happening.
Yeah, that has happened, and it's not necessarily a UCF, excuse me, oh my God, a UCF specific thing. There's an unfortunate pandemic of CS students who go through school, they get good grades, they graduate, and they might not know what a pointer is. Very important things. So we've also got to make sure that we are strong with the foundations, to make sure everyone is on track. Those are both also perfect answers. So for UCF in particular, it's to make sure you're prepared for your upper level courses. The issue that they used to have, I think it was 20, 30 years ago when they first started this, was people would take Intro to C and CS1, they'd do fine, and then they'd go on to your upper level electives, and they didn't know what they were doing. So it's essentially to make sure that when you go on to those upper level electives, you are prepared and you can succeed. Because, there's a lot of interesting, unique, novel stuff that you do in those courses, and you really need to know how to code. If you were trying to write a novel, first you'd want to make sure that you have a proper understanding of the language you're writing it in. So it's sort of like that. It's also, in my opinion, to demonstrate that you do know how to study efficiently. The foundation exam isn't something where, if you just did pretty well in CS1, you can walk in and pass it easy breezy. You need to be able to study. You need to be able to commit time and devote yourself to making sure you pass it. And I think that the skills you gain from studying and from making sure that you can pass the foundation exam are super important when you need to study for your later classes. So does anyone have any further questions about the foundation exam for right now? Questions, comments, concerns before we move along? Okay. So, different vein. In terms of just your college career, what are some general resources you use? Websites, links, things that you utilize to help you with assignments, to help you with your grades, to help you study. It can be a website, it can be in person, it can be physical.
I noticed that I like to watch YouTube tutorials for discrete math. Like I find those to be helpful.
Yeah, I agree. I think especially with discrete where there's so much like equation writing, it's very beneficial to watch someone draw out the process and to not just like read or hear about it. Me personally, I'm very much a visual learner. So like if they're not, walking through every step and annotating as they do it, I have a hard time seeing like what has changed from equation to equation. Um, Anyone else? There's one like super recent, super obvious one that I'm sure several people are currently thinking of.
Oh, ChatGPT or Gemini.
Yeah, there it is, ChatGPT or Gemini. So let's talk about AI quickly. We all knew it was coming. So before you use it, in any context, in any situation, please verify its use with your professor's syllabus. Please verify its use with your professor's syllabus. It varies from professor to professor. It varies from class to class. Please verify its use with your professor's syllabus. In no circumstances should you just be generating code and turning it in. There's literally no situation where that's going to be either helpful for you or legal under UCF's rulebook. Use of AI to generate like code segments, bits of it to help you see what kind of code you should be writing. Again, please verify its use with your professor's syllabus. So an example of a good use that would probably be allowed is asking ChatGPT to explain, hey, what is a pointer? That's, like Googling something. That's a little okay. Or asking it, hey, here's my code. Can you give me a hint as to where I'm going wrong? Why might this not be working? Also might be okay, since you're not just having it edit your code or create code itself. Excuse me. Bad use. Please do not copy paste your assignment rubric into ChatGPT. And please do not just vibe code the rest and say, well, I'm just going to change a variable name here. I know that AI checkers aren't always super accurate, but it is still kind of easy to tell when code has just been written by AI. It follows like certain naming patterns. If I plug in the same rubric to ChatGPT, it's going to show me your code, and that's not going to be good. So one more time. Please verify any AI use with your professor. I've had professors who say, under no circumstances should you use it. I don't even want you to use it to troubleshoot, nothing. And I've had professors who the whole assignment was, hey, generate all of your code with ChatGPT and tell me the prompts you used. So very, very dependent. Okay, paste any questions you have about the use of AI, now, and I'll answer it as we go, okay? So other general resources, some of the obvious ones for comp sci, Stack Overflow, sort of the classic go-to. If you're new to CS, you're going to see Stack Overflow a lot. If you've been here for a while, you have seen it a lot. Sometimes it can get a little bit into the weeds with the explanations. You'll go to ask, how do I write a print statement in C? And they'll start talking about, well, which operating system are you using? So you have to be sure you can parse through the information, but it's still very useful. Other ones, W3 Schools and Geeks for Geeks, they're great for learning, especially like intro level with Intro to C or Python. Lots of great, like lessons, resources, very thorough explanations. So I'm always a big fan of using it even now. The actual code documentation, it's there. It's like the Bible of the language. It's probably the most difficult to use, but it would also give you the most thorough answer. And as we have already referenced, YouTube videos, tutorials, and again, Professor Guha's website. I can't recommend it strongly enough. Professor Guha's website has notes on everything from Intro to C to Discrete to CS1, and they're all very thorough and very well explained. So now in general, a little bit of a silly question, but what is a study skill other than a skill you use to study? Do I have any takers?
Systematic method.
Good. Yeah, like a method you use to study, right?
Right.
Yeah. So study skills are tools and strategies or methods you use to effectively learn and retain information. Keyword here is effectively. Ineffective study strategies often hurt your ability to succeed. So no playing an all-nighter, slamming back a Red Bull, spending all night in like the night study. That is not a study skill. That does not count. Please do not do that. If you have to do that, you need to work on your other study skills. So what are some effective and general study skills that you guys can think of? Like, if I was just going into college, what do you think, someone would recommend?
To like stay organized.
Awesome. Stay organized, use a planner, have a whiteboard. Great. We've got group studying. I agree completely. Getting together with another person or multiple people and holding each other accountable. Key thing with group studying, be sure the people you're with will actually hold you accountable. It's different between like getting together with people in your class and going to study and getting together with your friends and going to Starbucks to try to study. I have done both. The second one is not effective. Any other examples from anyone? Office hours, great. Yep, your professor is paid to be there. They get lonely. They sit there and they eat like a salad that they bought from Publix and they check their email. I've seen it. They do want you to go. You are not bothering them. Go ask questions in office hours. So we've actually talked about a couple of them, but a couple other ones. I'm a big fan of the Pomodoro method. If you haven't heard of it, essentially you study for 25 minutes, you take a break for 5 minutes, and you repeat. There's all sorts of like timers like that on YouTube. If you just Google or go to YouTube and type in Pomodoro timer, there's like lo-fi ones. There's this one like animated lo-fi one with like these little cats that go across the screen. I watched all of them. So it's supposed to help with your focus, especially if you have a really bad attention span. And as you build up your focus, you can increase to longer times. So like 30 minutes in 5 minutes or 50 minutes in 10 minutes. And before you know it, like you've actually incrementally done a lot of work. We talked about public study, staying healthy, healthy body, healthy mind. I know that's like sort of an idiom at this point, but genuinely feeling healthier will help you study. Increased blood flow and circulation helps you sleep better at night, which helps you wake up feeling properly refreshed, which helps you study. I know it sucks, but being healthy is actually healthy for you. I know it's a controversial statement. And another one, reading through your PowerPoints before class so you can keep up with the professor's lecture. I'm a big fan of that one because sometimes professors go too fast. I don't know if you've ever tried to like, I'll reference discrete again, like write down equations and then they write them down too fast and erase them and you're left not knowing what a variable is and not knowing like where they went from it. So read it beforehand, you'll go in knowing what you're doing. You're here for like computer science? Cool. So now, what are some computer science specific study skills that you guys can think of? Things that would specifically apply to courses you've taken, things that you've done to help you with your classes.
Pseudocode assignment, coding assignment.
Pseudocode, yep, that's a great one. I didn't even write that one. I don't know why, but
Oh,
like essentially, if you don't know, pseudocode is, I guess, like the English explanation for what your code should do. So, if you want to say, hey, I want to write code that says, while there's characters in the string, we are going to read each character and print it. And you just write that out. And then when you go in to write your code, you know what everything is supposed to do. Practicing leak code questions. That's also a good one. So if, again, you don't know, leak code is an online resource with a bunch of like practice coding problems. It's infamous is a good word, I guess, in the comp sci community because interviewers also typically like to use leak code questions when you're applying for jobs and internships. Just be sure that you're effectively using it. Use ones that are related to your class. Um, it's great if you're like really good at leak code and you can solve all the like dynamic programming and complex problems. Be sure that you're spending your time effectively and doing problems that are relevant to your classes. Any other ideas? Building mini projects, that's also a great one. The best way to learn is to do it yourself. And I talk about this a little bit later, but if you're ever like, how does this data structure actually work? How does the process of like, creating memory for this actually work? How does this algorithm actually work? Go code it yourself, preferably code it in C. I know it's easier to do in maybe other languages, but C is sort of the base off which most of them are built. So if you know how to do, a binary search tree in C, you're going to understand it better. So we're going to get into a whole bunch of study skills. So I believe that this recording will be posted online. If you ever want to go back and watch it, I think the PowerPoint will be posted as well. But I would really recommend, writing down whichever ones of these you find useful, and we'll continue to share them as we, excuse me, as we go along. So bear with me, we have a lot. Commenting your code. When you are going through and you're doing your assignments, I know that your professors say like, oh, you should comment your code. Some professors even say you have to comment your code. If there's no comments, we don't know what you're doing, so you're going to lose points. Get in the habit now. Because if you say work on a project for a week and then you leave it for 3 or 4 days and you come back to it, you can look at it and have no idea what's going on. I have done that before and I've had to rewrite all the code because I had no clue what I did. So just comment the code, write little notes, say, oh, I want it to do this. Input is this, output is this. Brief little explanations, doesn't have to be every line, doesn't have to be 3 paragraphs. Just like, this is a really weird example, but like when you're playing Minecraft and you're like going through a cave, you leave torches behind you so you know where you went. Leave yourself some torches. Set up your IDE to automatically format your code. I think they're called delinters, if I'm not mistaken. Essentially, it just makes it prettier. That way, like all the indentation looks correct. You can really easily visually look through it and know what you're seeing. Sometimes, especially when reading other people's code, it can be difficult to figure out where things are just because of the way that they maybe indent things differently from you, or they, use different variable names. So tools like that help you consistently process your own code. Another one, get comfortable with your debugger. It helps you, see, hey, this function was called this place at this time, this many times with these values, and here's the value of variable X at this time, and then it changes to this, and using breakpoints and all of the fun and interesting things that people creating VS and VS code get paid to implement for you to make your life easier. You can find a YouTube tutorial. You can read through the documentation to see how it works. I would really recommend it. You can also just slap a print statement in there and say print the value of X. That's allowed. No one's going to stop you. It can be helpful if like you just want to see the final output. I would just also recommend getting comfortable with the debugger.
Or throughout your code.
Yeah, also throughout your code. Like I'll admit it, sometimes I do it. You know, if I have a for loop, I'm putting a print statement in there. I'm going to see like how the value changes as the for loop runs. I'm going to see how many times something is called, like especially before and after functions. If I have a function like, you know, square, like where I want to square a number, I'm going to put a function before saying the value of X. I'm going to put a print statement after saying the value of X. So I can see if it got squared. You can do that in the debugger. It's probably easier. The print statement also works. And excuse me, if you have any like questions on any of the study skills we've talked about or any additions to them, please leave them in the chat or on mute. They're totally welcome. So even more study skills. Okay. We mentioned going to your professor's office hours. Very useful. Again, they are paid to be there and they're lonely. Go say hi to them. You can also build up a rapport with them and maybe they'll have research or maybe they need a UTA or a ULA. You never know what you can get by going to talk to them. So just go say hi, go ask them a nice question about the assignment, be on your merry way. I promise it's helpful. There's also the concept of pair coding. So we've talked about like group study where people hold you accountable. The idea of pair coding, if anyone hasn't heard of it, is essentially you work with another person. And as you're writing your code or explaining your code, you're just talking them through it, talking through what it should do, talking through like what the outputs are. And many times as you do that, you'll realize, oh, the code isn't doing what it's supposed to do because of this. As you try to explain it, you'll realize where you went wrong. I read a story about there's like a startup that had an odd number of people. So, you know, a couple people got set up in pair coding and one person got like a giant stuffed animal. And they just explained through the code to the stuffed animal. And there would be times when they would start like freaking out because they realized like, oh my God, I know what I did wrong. And it's because I explained it to this giant stuffed giraffe. So explain out your code. Another one is run your code after every functional change. Just be sure that you know like if there's an error or if there's a change, where it came from. If let's say, you know, you have like 5 lines of code and it runs, and then you add 150 lines of code before you run it again and you get an error, you now have to check 150 lines of code. It's much easier if you do it incrementally. If you say, okay, let me add this 10-line function. Let me add this 15-line function. Let me add this 20-line function. And after each change, you run it, you make sure you're getting what you expect so that you're properly building off of it instead of like creating this rickety scaffolding of code as you go up. Okay. We talked about coding it in C. Also segmenting your projects into unique deliverables. So if you have like, say a function to do the quadratic formula, right? X equals negative b plus or minus the square root, b squared minus 4ac all over 2a, right? Have functions to do each individual part of it. Say like, okay, I have a square root function. I have a numerator function. I have a denominator function. I have a final function. That way, like each individual part of it can work. It can work independently. You can more easily identify where the issues are. Okay. So we're going back to the foundation exam. I'm sure many of you are happy about that, and I'm sure many of you are not, but it's still important. So either from personal experience, from people who have taken it, from people who are preparing to take it, what kind of ideas or skills do you have for the foundation exam? Like, what do you think would be helpful for people to know? Anyone got anything?
This isn't, I'm just checking, the computer science placement exam is something. So
Yeah, that's different. So
that's the bypass.
that's to bypass concepts. Yeah.
Right.
So if you pass the placement exam, or if you get, I think, a certain score on like AP computer science in high school, you can bypass concepts. The foundation exam is different. It's
Okay.
for like after you pass CS1 in college. We've got never underestimate it, but don't psych yourself out of doing well. It is possible to do well even on your first try. Absolutely. It's it's scary because it has that big threat of like, oh, if you don't pass it, you'll fail. You do have 3 attempts. You do have a lot of time on the exam, and you also know exactly when it's going to be. You have a lot of time to study. So as long as you prepare effectively, it's super duper doable. So we will go on to the study skills for it. My recommendation is to make the absolute most of all of the old exams. Pretty much all of them are relevant. Pretty much all of them are still the type of question you'll see this semester, next semester, and the semester after that. This is your #1 resource. Make the absolute most out of the foundation exams, the old ones. My recommendation, me personally, what I did, I started preparing, I think it was closer to 3 weeks to 4 weeks prior to it. And at the start, just ease yourself into it. Go over the different types of problems from all 4 sections. So that's data structures 1, data structures 2, algorithm analysis, and algorithms. So do, a couple questions from one, a couple questions from the next. Make sure you're comfortable with them. Make sure you're used to them. And as you go along, start doing more, and then start trying to do a practice exam for yourself. So you can do that by just doing like one section at a time. Do data structures 1, time yourself as it would be on the foundation exam, and then go over your answers. Work them through with people who are taking the exam with you. Do group study like we discussed. Do like pair explanations. So saying, yeah, this is my answer and this is why. And also, if you want to, you can rent out like a room at the library, and they typically have whiteboards on them. So bring an expo marker. You can also get those from the front desk in the library if you don't have any. And draw out like your explanations for your answers. The foundation exam is written, so it's very useful to know what you have to draw out, what you have to write out, and know what you're going to put as your answer. And then you can take a picture and then erase it. So I would really strongly recommend at least 2 weeks prior to the exam, preferably earlier, you start preparing and you eventually start taking full-length practice exams. That was the #1 way that I did it. I passed on the first try. It's a little nerve-wracking. Make sure you really study algorithm analysis because it's probably the one section that people are most like confused by. Here's the one section I was most confused by because it's not code. Yeah. If you have any questions about the best ways to study for the foundation exam or other information, please feel free to ask. You can unmute, you can leave it in the chat, any way you want. I know it's very stressful for people. It's very common not to pass on your first try. It's common not to pass on your second try, so it's okay. Don't psych yourself out, like Gabriel said. Just make sure you're preparing effectively and you'll be fine. So what about group projects? Depending on where you are, you may or may not have had them yet. I think really the big one, the big first one that you'll have is POOSD, so Processes for Object-Oriented Software Design. Terrible, terrible name, I know, but you'll have basically, as long as it stays the same, 2 group projects in there, and eventually you'll have to do senior design. And that is a group project, and there is nothing you can do about it. CDA, is there a group project in CDA? It's been a while. I wouldn't know. Maybe in CDA then too. So yeah, from people's experience, what has helped you in any of the group projects you've had thus far? What were some positive things? And if you want to share, what were some negative things? What were things that like went wrong in your group project? I know typically everyone has some horror story about a group or a member of a group who did something crazy, got like arrested or dropped out, things like that. So now is the time to politely and respectfully vent, if anyone has it. For me personally, I had for one of my classes, one of my group projects, it was a 6-person team, and 3 members of my team went on a week-long sabbatical for a club that they were in and didn't do any work. So that was fun. Splitting the work equally, absolutely. Make sure that the work is apportioned fairly, correctly based on people's time. Anyone else?
Frequent checking.
Frequent check-ins, absolutely. I have a note on that. You can create like a team Discord, team group chat, whatever you want. And daily, every other day, just leave a little note like, hey, here's what I'm doing. Other things, you should hold at least weekly in-person face-to-face meetings. When it's on Zoom, at least for me in my experience, people, don't have their cameras on, so they don't pay attention. They're not really focused. They kind of don't unmute their mics, especially if you guys don't know each other that well. So in person, face to face, where you can visibly see other people and physically show them like, hey, here's what I'm doing. Other tools and resources, using an organizational tool like Jira. So that's for like agile development, which when you get to processes, you'll learn more about. Essentially, that's like what we talked about before with incremental development, where you create, smaller functions that work independently as you go along. And that way you can just manage like, hey, here's the things we need to do. You have a list of them all laid out by, urgency and difficulty. If you use it correctly, it is a good tool. Creating clearly defined roles and explicitly stating the inputs and outputs of each role, especially as you get bigger projects like in Boost and like in senior design, you're going to have some overlap in what people think their responsibilities are. And poorly defined roles is typically the #1 source of chaos and confusion in a group project. You'll have someone think that they're supposed to be handling a certain output. Someone else will think that they handle that output. You have 2 people working on the same thing. Something got, chucked to the wayside and you're not doing it. So make sure everybody knows what everyone's part is. We talked about regular meetings. We talked about dividing up the work. And this is another one you'll learn if you ever have Dr. Lineker. Do what you say you will do. If you say, I'm going to do the front end, do the front end. If you say, I'm going to, write out this code today, write out that code today. That's building trust is the best way to make a group project go forward. If you have any other questions about working in groups or anything like that, please, raise your hand, leave it in the chat, unmute your mic. Otherwise, we will move on.
Is there any like Google workspace, like for, like I'm thinking like post code there, even if you don't make it editable? Right, like that way they could see it and even copy it and use it?
Yeah,
Like a
so
common thing?
typically that would be done with GitHub. Have you been introduced to GitHub at all?
Brief.
Okay. Yeah, I should have absolutely included that. So GitHub is what's known as a code repository. And so essentially, when you work on a group project, everyone on the project can have access to this GitHub where everyone will upload their code, download other people's code, and be able to work with the most recent version of the code.
Okay.
So that way, let's say you have Tim and Bob. If Tim is working on part A, Bob is working on part B, Bob can upload his part and Tim can then download that part and work, in the comprehensive version of the code. GitHub is another resource that you really need to take time to learn, because otherwise there's situations where maybe you accidentally overwrite the code with an old version. Maybe you didn't pull correctly. There's all sorts of like niche situations that can be bad with it. So it is really important to like fully learn how it works. That's better done in a YouTube video or an online tutorial. There's literally, that's like a whole nother presentation in and of itself. So
Right.
know the word GitHub, learn it on your own. It's useful. So other class specific study skills, I will just go ahead with that. So specifically for some of your earlier courses, that's COP 2500, COP 3223, and COT 3100. So that's concepts, intro to C, and discrete, and computer science 1. I forgot. We have supplemental instruction for those courses. We also have peer tutoring for those courses. So that's the peer tutoring resource that I told you about earlier. It's offered by UCF. It's completely free. It's what I work with. It helps you not only learn the content, but how to better understand and learn the content on your own, so that that way, as you continue along, you know how to study the content. COP 3502. You can also use old foundation exams for Computer Science 1. Computer Science 1 is the basis for the foundation exam. Therefore, the foundation exam is helpful to study Computer Science 1. So if you have questions about like data structures, use the data structures section in the foundation exams. Another one for processes for object-oriented software development, LinkedIn Learning. As long as it's still there, which it was when I was in undergrad, so very recently, if you create a LinkedIn account with your UCF email, you should have free access to LinkedIn Learning. So these are basically like online tutorials and classes that teach you, different computer science subjects. So JavaScript, React, SQL, Python. And while you learn, once you finish the class, you actually get a little certification on your LinkedIn, which I don't know if employers look at it or not, but it's kind of like a nice shiny badge to have. I found it really useful, but thank you, Al. I see your message. I find it really useful, so I would recommend anyone to use it. Okay. So now we're kind of going to do like a group activity. I know, I know. So all I really want you guys to do is provide an example of, some situation you face thus far in the major, whether that's a difficult assignment or a difficult project or a difficult exam, and just tell us, why it was challenging. And then the rest of us can communicate some of the strategies that we've learned in order to overcome it. And I want you guys to write those down while you do that, because that way, like when you face a similar problem, especially if it's from someone who is further along in the course than you or further along in the CS flowchart than you, when you get there, you know what to do about it. Does that make sense to everyone? So you can either unmute, you can say it out loud, you can type it in the chat, just like a difficult concept, a difficult exam, a difficult project, something like that.
So do you have counter examples in state structure?
Counter examples. Do you mean like, I guess, what do you mean by that? Oh, sure. Yeah, sure. Mhm. Yeah, we have like, it's been a while. I can't remember what it's called, but essentially like doing something to show like in one instance, the proof doesn't work.
Right.
Right.
Yeah. Very challenging.
that makes sense. So we have trying to come up with like a counterproof on the fly. So thinking about like in discrete, how would you disprove something, or how would you come up with an example that you know will break the proof? So that's a good one. We have Viv says, I was struggling with an assignment in COP 3223, so I went to the TA's office hours. It's great. Again, office hours exist for that. Going back to your example, one of the things I try to do is there's usually some sort of pattern to like the point that will break a proof. So, think about like an edge case that would break code. What happens when a set is null? What happens when a set has 0? What happens when the numbers are too big? Does it apply when I don't know, I apply every function to it? Essentially, it's sort of like a Rubik's Cube where you just have to twist it a whole bunch.
Yeah.
And as you practice it and do practice problems either from the book or you Google them, you end up being able to identify them more easily.
Yeah, with code, I think you try to break it, get the errors, then but with the math.
Yeah,
right,
linear
I mean,
algebra
you're
is a
trying
bit
to figure out
hard.
how to
Yeah.
make it work instead of how to break it. I think that.
Okay.
But, thank you.
Other ones are Excel projects for TAs, attending a workshop. CDA has tough material. Explaining what I was trying to achieve definitely helped and guided me to where I needed to look. Yeah, I know CDA is a difficult one since it's sort of like computer architecture type stuff. It's more like engineering work. So yeah, explaining it out, trying to rationalize in words what's going on rather than just the visuals of the gates and whatnot. Struggling on quizzes, so studying with a friend. And yeah, especially if the friend is, doing better than you in the class, it's okay to talk about that. It's not taboo to, discuss grades with your friends. So having someone else who you know help you out, that's a really good one. And making friends in the classes you're struggling in. Study groups are super helpful, absolutely. I mean, there's a reason why we want you guys to go in person, and it's not just to watch the lectures, it's so that you can talk to the people around you. Because maybe the person next to you knows what they're doing. Maybe they don't, and you guys are both stuck, and you guys can go to the library and work it out. Study groups, learning in groups, learning with another person, probably the most effective way to study and to learn. Okay. All right. So we're going to sort of finish up here with what's actually, we have this handout at the end of the table as well. If you want to see it here, it's also here. These are just some tips on like ways to improve your concentration. That's not really necessarily the focus of this presentation, but I do think it's useful, especially for computer science, when we're literally always on our computers, always on our phones, especially in this major. It's very easy to get distracted. I'll be working on code and all of a sudden I'm like on Twitter. So just, a couple skills, a couple tips, a couple useful resources. So you can either take a screenshot. If you're here in person, we have a physical handout. But otherwise, that's all that we have for today. If you want to scan this QR code, this is for an evaluation. So if you think I did a good job, you can scan it. You think I did a bad job, you can also scan it, but I hope you don't. If any of you need the attendance QR code, then please just say like me in the chat and I can go back to it as well, since that one's a lot more important. We would like to know that you're here. Awesome. Okay, so we do have people who do need it. Okay. So this QR code right here is the one that you need for attendance. So please go ahead and scan it. It's going to take you, if you weren't here for the explanation earlier, to what's called Penji. When you're in Penji, if you haven't signed in, you're going to sign in with your UCF email. So that's the first 2 letters of your name and then the 6 numbers at ucf.edu. Then you're going to navigate to this event, code your success, and say it's like join event, join now, something like that. Okay? If you have any questions, if it doesn't work, then please, unmute or leave a message in the chat and let me know, and I'll do my best to help you. This is how we know that you're here. So if for whatever reason it just doesn't work at the end of the day, I can do my best and go into like the Zoom records to see who was here, but this is like the easiest way to do it. So once you've scanned it, no remaining occurrence. Okay. Let me double check and scan it. Your impact form, I am not sure what that is. Um, can you explain what that is? Sure, you can email it to me. If it's something that I can do, then I'll do it for you. If it's something that I need or that I know who can do it for you, then I'll let you know. So my email is right there. Do I need to fill in something to get a certificate for my attendance? You just need to scan that QR code. If the QR code doesn't work, then I can go into the Zoom and verify that people were here. Right, I was going to check to make sure the QR code is still working. Um, okay. So I think because the workshop has ended, yeah, the workshop has ended, so the QR code isn't going to work anymore. Let me see if I can pull up the link for you guys. Um, let's see here. Hmm, here, copy. You guys can try that link and let me know if it works. Otherwise, I'll just have to go back through the Zoom and verify people's attendance. So I know, Mohammed, you needed verification for your attendance, so I will copy your name down. Share.